Alright guys, so welcome to a brand new video. So in this whole video, I'm going to teach you guys TypeScript. We're going to start with the basics and we're going to work our way through all of the basics and then move on to a little bit more complex TypeScript stuff. And then if we have time, what I'll do is I will show you guys how you can actually use TypeScript with already existing modules, for example, such as Express, Discord.js, and etc. So a couple things that I want to mention before you get started with this video is that this video does imply that you already know JavaScript. So I would highly suggest you learn the basics of JavaScript, but not only just JavaScript, but also learn the basic fundamentals of programming. So make sure you understand loops, make sure you understand functions, methods, classes, make sure you have a solid understanding of object-oriented programming, obviously understand what variables, data types are. And once you feel like you have all of those basics down, then definitely come back to this video. In the community of JavaScript, a lot of people tend to recommend you to learn JavaScript first and then TypeScript. However, let's say, for example, if you already have programming experience and you have programmed with, let's say, a language like Java or C# or C++, then honestly, I think you could still follow along with this video, because a lot of times when people first learn JavaScript, a lot of times they rarely ever touch the OOP stuff, the object-oriented programming stuff. That's because JavaScript does lack a lot of those features, such as generics, abstract classes, interfaces, but TypeScript also has those features. Now, we're going to talk a little bit more about what exactly is TypeScript and what makes it different than JavaScript. So let's go into the next slide. All right, so first of all, what exactly is TypeScript? Well, TypeScript is basically a statically typed programming language, and what that means is that the data type of a variable is known at compile time. So you have many different types of languages, and for example, you have a language that's dynamic like JavaScript. So all of the data types are actually known during runtime rather than actual compile time. So with statically typed languages, basically what happens is you first compile them down. Okay, and during compilation time, it will actually know what the data type of the variable is. So a language like Java is compiled, and Java is also a statically typed language as well. With TypeScript, it being statically typed means that we need to actually use a compiler. So we're going to use the TypeScript compiler, and we're going to write our TypeScript code. We're going to compile everything down from TypeScript into JavaScript. Okay, now during compile time, it's going to know what the data type of a variable is, rather than when we run the program, it's going to infer what it is. Okay, so that's kind of like the main difference between statically typed and dynamically typed. So as I mentioned already, TypeScript is transpiled down to JavaScript. So basically what this does is we use the TypeScript compiler to transpile all of the TypeScript files into JavaScript files. So the reason why we do this is because the browser, for example, if you want to build a website with TypeScript, the browser actually cannot interpret TypeScript, at least not yet. Okay, so what we do is we actually transpile all of our TypeScript files into JavaScript, and then the browser or Node.js, whichever environment you're running your apps in, will actually be able to interpret the actual JavaScript file. Okay, so you can actually use TypeScript to substitute, to replace JavaScript, and you can build your applications, and then you can transpile everything down, and then everything will work just fine. So, like I mentioned earlier, JavaScript is an interpreted language rather than a compiled language. And basically what this means is that all of its source code is being read and understood while the program is running. That's what an interpreted language does, right? It has an interpreter, and the interpreter will pretty much read and understand the code as it's being ran. Whereas compiled languages, they first are compiled down into either machine code. Usually they can be compiled down to a different source code. But with TypeScript though, it's actually transpiled into JavaScript, and then it uses the JavaScript interpreter to actually interpret the code. So ultimately, I wouldn't really, consider it like purely compiled. That's why they say transpiled instead of compiled, because when you transpile code, you're really transpiling source code into another form of source code, which is what it's doing with TypeScript and JavaScript. When you actually compile a language, you're usually compiling it down into bytecode. Okay, for example, Java compiles everything down into bytecode, and that bytecode is being used to that bytecode is actually thrown into the JVM, the Java Virtual Machine, and then it's going to be ran. Okay, as I mentioned over here, compiled language is first compiled into machine code and then ran with their respective virtual machine. Okay, and then like I said before, JavaScript is also a dynamic language, which means that the data types are checked during runtime rather than compile time. All right, so a lot of people always ask, well, what is the main difference between TypeScript and JavaScript? Well, first of all, let's just mention that TypeScript is just a superset of JavaScript. And what this means is TypeScript actually extends JavaScript. There's a lot of features that are in TypeScript that are not available in JavaScript. However, all the features that are already in JavaScript are in TypeScript. They're valid, okay? So basically, all valid JavaScript is also valid TypeScript, but not all valid TypeScript is valid JavaScript. Okay, there's a difference. It doesn't work vice versa. So pretty much it also being a superset means that it has a bunch of extra features that JavaScript lacks. And one of the ones that I mentioned earlier was the type system, as well as the OOP, the object-oriented programming features, which we will take a look at in this course. Okay, so there's a lot of TypeScript features such as interfaces, enums, type annotations. They have different types, literal, union, and intersection types. So we can use these to create our own custom types. They have generics, abstract classes, access specifiers, and etc. And like I said, a lot of other OOP features. Okay, so now let's ask the question, why should I learn TypeScript? Okay, well, TypeScript's type annotation feature, so in case if I didn't really talk much about it, basically in JavaScript, we don't have explicit data types, right? Types are pretty much inferred. Now, we do have data types. We have numbers, we have strings, we have booleans, but those are inferred during runtime. They're not known during compile time. Okay, so this can actually lead to a lot of potential bugs and vulnerabilities because you might be able to, well, not might, you will be able to throw in, let's say, a numeric value into a function that expects a string, and that could actually break your entire program. Okay, with type annotations, it makes our applications much more robust, so that way we know exactly what arguments are being passed, or what data type are being passed in as arguments, and what we're taking in for the method. Okay, but with TypeScript's type annotation, it pretty much allows us to make our programs much more robust. It doesn't allow us to throw in incompatible data types. We also have a rich set of object-oriented programming features that we can use, and with a lot of other additional OOP features, enables us to build complex architectures with, design patterns and a bunch of other things. And it can also, if you use React, TypeScript can also save you a lot of headache. So, for example, in React, you probably use a library called prop types to validate all the props. However, if you have TypeScript configured with your React app, you can just use TypeScript's already custom types. Alright, so now I'm going to show you guys how to get started with TypeScript, writing your first TypeScript program. The first thing that we're going to do is I'm going to open up my Windows terminal. You can use a command prompt, or you can even use the Visual Studio Code's terminal. But we're going to open up our Windows PowerShell. Now, obviously, you need to make sure you have Node.js installed. Okay, you also want to make sure you have a text editor of your choice installed. So I use Visual Studio Code. You can use Atom or IntelliJ or whatever you want. Well, IntelliJ is a IDE, but you can still use TypeScript if you have the premium version or the ultimate version. So I'm going to go into my documents folder, and I'm going to make a directory called TypeScript crash course. So I'm going to make a directory. I'm going to just cd into that directory. And the first thing that we want to do is let's go ahead and actually install TypeScript. Now you want to install it globally. So you type npm, or if you're using yarn, you can just type yarn -g TypeScript. I think for yarn, it's yarn global add or yarn add global TypeScript. But I'm just going to use npm. So we're going to install TypeScript globally. Now I already have TypeScript already installed, so it's just going to say updated, but that's fine. So now we should have this tsc command, and if it works properly, it will output all of this. Now, if you get any errors, let's say, for example, if it says tsc is not a valid command, it's very likely that your npm path is, your global node modules path is not configured. So I would just say Google how to fix that. Just Google something like npm global modules not working. And I promise you, you'll be able to find a solution. If not, just join my Discord server and we'll try to help you out. Okay, but assuming that everything works fine, you should have that tsc command. So now pretty much we can use this command to compile our TypeScript files. Okay, but what I'm going to do is I'm actually just going to go ahead and open up Visual Studio Code with this directory. And I'm going to go ahead and just create a file called index.ts. And I'm going to just simply say console log hello world. And remember, like I said, all valid JavaScript is also valid TypeScript, but it doesn't it doesn't work the other way around. So if I want to, I can actually just use node index.ts, and this will actually work just fine. Now keep in mind though that this only works because we have valid JavaScript inside valid TypeScript. But if we actually were to use actual TypeScript features, let's say if we had an interface, right? So I'm just going to create an interface. I know you guys might not know what an interface is, but don't worry. I'm just going to do this for now. But I want to show you what happens. You're going to see that we actually get a syntax error. That's because the node interpreter cannot understand this interface. So it'll work for valid JavaScript, but once you actually start implementing actual TypeScript features, you won't be able to actually use a node interpreter. Now what you can do is you can actually install something called tsnode. So I actually don't have tsnode, so I can just install it globally. And tsnode is pretty much just another interpreter, but it's pretty much like a node interpreter, but it supports TypeScript. So I can just do tsnode. And you can see that if I do index.ts, it'll literally work the same way. You'll see that it's a little bit slower because, like I said, it has to do the transpilation. Now let me go back and put that interface there, and you can see that it'll work just fine. Okay, so yeah, you can use tsnode if you want, or you can just transpile it down, whatever you prefer. Okay, so let's go ahead and do a couple things. Let's type in tsc --version so we can see the version of TypeScript, and that as of this video, our version is 4.1.3. Okay, now one thing that I would recommend you guys do is you should also initialize a TypeScript tsconfig file, and you can do that by typing tsc --init or tsc space --init, and you'll see that we have this tsconfig.json file that's created. So this is pretty much just a configuration file that defines a bunch of fields for us, that tells the compiler how to actually handle the I shouldn't say compilation, I should say transpilation. Okay, but pretty much this will allow us to determine how we want to transpile our project and a bunch of other things, like what files we should include, where it should transpile the JavaScript files to, and etc. Now there's a lot of stuff in here, so don't worry so much about every single thing. We can honestly just leave everything alone. But basically, you can see over here we have target. So this pretty much specifies which ECMA script to target. So it's targeting ES5. And we're also going to do one more thing. We're going to go ahead and uncommon outdir. So this outdir is basically where we want the actual transpiled files to redirect to. So I'm going to name it dist. You can name it lib, dist, output, whatever you want. But now all we can do is we can do tsc. And you'll see that a new folder is going to be created called dist. And you can see it has this index.js file. And as you can see, we have a console log hello world. Okay, very simple. All right, now another thing that I should also mention is that right now with our tsconfig.json file, we have it set to strict, and we have a bunch of other fields over here. So with TypeScript, it also enforces a lot of strict checks as well. So for example, it ensures that it will always detect, any possible null checks. So if a variable could potentially be null, it will actually throw an error during the compilation process. So if this is something that you don't want, you can always disable strict. So you can set it to false, or you can actually explicitly set a specific field. There's a bunch of different modes, which we will definitely go over throughout the course of this video. Okay. But that's just something that I should mention, is that you can pretty much set some certain things to false if you really don't want them for the compiler. But I would highly recommend you keep strict mode to true, because that is one powerful feature with TypeScript, and it will honestly save you a lot of headache when you are testing your code, making sure it works properly. Okay. All right, so that's pretty much just the most basic setup when it comes to TypeScript. Literally now we can just write a bunch of JavaScript code and it will work just fine. So for example, I can write a function and just call it send message. And let's just, do something like args. And let's just say console log args. Now you're going to see right over here, I actually have a red line, and it's saying args implicitly has an any type. So in TypeScript, we're going to go over this in, I think, probably the next couple of sections of this video. But in TypeScript, there's a data type called any, and that basically literally means it could be any data type. It could be undefined, it could be a string, it can be a boolean, any. Now because we have it set to strict, right, it's always going to give us this red linting error, which says that parameter args implicitly has any type, which means that we cannot allow any variable to implicitly, right, just allow it to have an any type. If we want, we can explicitly state that it's any, and that error will go away. If you just want to leave it like this, then you can also disable this to false, no implicit any. and you can see that that error will go away. But that's honestly, I don't recommend it because like I said, you want to take advantage of TypeScript features. Okay, so we can just set this to any. And I'm gonna go ahead and just call send message, hello world. And don't worry if you don't understand what this annotation is. We're gonna go over it. I'm just giving you guys a quick preview. Okay, but that's basically called a type annotation. Okay, so let's compile, or let's just use tsnode. So index.ts. So you're gonna see it's gonna say hello world right over there. Okay, so that's just pretty much how we can create a simple function, but don't worry, we're gonna go over the actual basics in the next section of this video. Okay, so one thing that I will mention is that, like I said, even though you can write a bunch of JavaScript into TypeScript, sometimes you don't want to use TypeScript as if you're using JavaScript, because there are a lot of different ways that you could, write your code with TypeScript, and you want to try your best to avoid using TypeScript as if it was JavaScript. All right, so let's go ahead and move on to the next section of this video, and we're going to go ahead and start off with going over type annotations, and we're going to talk about the data types in TypeScript. All right, so in this section, we're going to talk about type annotations, and we're also going to go over the basics of functions in TypeScript. So like I said, if you don't know the basics of programming already, you need to go ahead and make sure you learn that. I do actually have a JavaScript tutorial, a full JavaScript tutorial for basics, that is, that teaches you all the basics of JavaScript and programming in general. So go ahead and check that out. I'll leave a link in the description to the playlist. But we're going to go ahead and talk about type annotations. Okay, so basically in JavaScript, right, we have all of our variables, all of the data types are inferred during runtime. Okay, so basically what that means is, let's say for example, I'll declare a variable called name, or actually let me call it first name, because I think name is already a reserved variable name, I think, and I'll just name it Anson. Now right over here, we know that the data type of first name is a string. However, the compiler, the program doesn't actually know this until we actually run it. Okay, now there's obviously some pros and cons about this, but in TypeScript, what we can do is we can actually explicitly annotate this variable for its data type. So for example, let's say if I know for a fact that this variable is going to be a string, then I can use the colon, and I can define the data type. So string is the data type, and I can assign it the value, the literal value of Anson. Okay, so you can see all we did here was we declared a variable called first name. We used the colon. Okay, and then after colon, we said, hey, look, the data type is string. And then we did the we used the assignment operator to assign it the value of Anson. We can do the same thing with numeric values too. So there's also the number data type. So let's just say const age. And like I said, we can assign it a variable, or we can assign this variable the value 23. But the compiler, the TypeScript compiler will not know what the data type of this variable is. Okay, so what we should do is we should annotate it as a number, just like that. So now the compiler will actually know at compile time that the variable data type of age, the data type of age is a number. If we try to assign a string to this, you're going to see that, let me do 23 in quotes. You're going to see that it's going to say type string is not assignable to type number. And that makes sense because we cannot assign a string to a number. That's incompatible. Okay, so you can kind of start to understand why type annotations are great, because this prevents us from being able to assign a non-compatible data type, or not, I shouldn't say data type, a non-compatible value to a variable that has an explicitly defined data type. So in JavaScript, we could probably do something like this, where we have const age equals 23, and then I could do something like, well, let me actually use let's, and age equals 23. We can do something like this, right? But as you can see in TypeScript, we actually can't do this because, like I said, it says type string is not assignable to type number, and it's giving us that error. In JavaScript, you could get away with this. In TypeScript, it won't let you. Okay, so let's go back here and let's just simply assign it to 23. Now, there's also the Boolean data type. Okay, so Booleans are pretty much just a data type that can either be true or false. So we can do something like const is male, and we can annotate this to be a Boolean. Okay, and we'll set this to be true is male. If I were to set this to a string true, it's going to give us that same error. Type string is not assignable to Boolean, and that makes sense. Okay, great. Great, so we have strings, we have numbers, we have Booleans, okay? All right, so now we also have the undefined data type, so const undefined value, undefined, and we can just set this to undefined, and that works just fine. Okay, if I were to give this an actual value, you're going to see that it says type DAS is not assignable to type undefined. Okay, so that's something that I'm not sure if you'll ever really need this, but you could possibly. And let's see, null value. There's also null, and then we can assign it to null. And there's also, remember, the object data type, so const object, or let's just say obj object, and then we can assign it to an empty object. And there's also the function const sum function. Okay, and if I were to assign this a string, you're going to see it says type string is not assignable to a type function. So we actually need to make this a function, and there you go. So now I should be able to just call some function, just like that. Okay, and if I wanted to pass in parameters, I could. So these are pretty much just the general data types that you've probably seen before, or you should have seen in JavaScript. Okay, but this is how we can explicitly type annotate our variables. Okay, so that way the compiler actually knows what the data type of the variable is. Okay, so now let's actually use these type annotations with functions. How do we do that? Well, first let's create a simple function. So we're gonna go ahead and do function output message. Now right now this function takes no parameters, but let's change that. So let's just say message is a string. Okay, and all we're gonna do is just say console log message, just like that. All right, so what we've done so far was we created a function called output message. It takes in one parameter, and for that parameter, we actually annotated the type. So the same way that we created our variables, we declared them and then annotated the type, we can do the same thing with the parameters. So message is a string. So we explicitly stated that message is a string. In the previous section, we did this already, okay? And you can see that if we don't have that string type annotation, it's going to give us this red line, which says that message implicitly has an any type. Now, the any data type, like I said before, literally means that it could be anything. It could be a boolean, it could be a string, it could be a number. You really want to avoid using any. The only time you'd want to probably use this any type is when your data being passed in is non-deterministic. But at all costs, try to avoid using any. Okay, so let's go ahead and leave this back as a string, and now let's go ahead and call output message, and let's just say hello world. And now if I go ahead and if I want to, I can compile everything. So you can see that if I look inside the index.js file, you're going to see we have our function, and we also have the function being called, and it's passing in hello world. And you can look at the difference too, that all the TypeScript is literally transpiled down into JavaScript, and you can see that this actually is valid JavaScript, and it can actually be ran. If I type node dist index.js, it's going to work just fine. Okay, so that's pretty simple, right? Pretty simple stuff. Now, what if I try to call output message and I passed in a number, 23, for example? You're going to see that we have a red line. If I were to try to compile this, it's going to throw an error, a compilation error. Okay, it says argument of type number is not assignable to parameter of type string, and that makes sense. We cannot assign anything that is not a string to this function. Okay, so we have to make this a string in order for it to work. If I pass in a boolean, if I pass in a undefined value, if I pass in null, if I passed in, an object, a function, you get the idea. It's going to throw the error. And this basically is great because in JavaScript, it doesn't do stuff like that unless you have a linter. Okay, but since TypeScript will do that for us, we can safely assure that, if you properly follow this pattern where you type annotate all your, function parameters, you can be very confident that there's nowhere in your program that has incompatible data types being passed in. Okay, that's assuming that you properly follow the same practice. Okay, but that's pretty much type annotations with function parameters. Now we can actually also annotate the return type of function. So if you're not familiar, remember functions functions can actually return a value. So for example, a function can return literally anything. We can return a number, we can return a string, we can return an object, okay? Well, right now this function actually returns nothing. It's a void function, which means that it returns nothing. So we can actually annotate this to be void, and it will be just fine because it doesn't return anything. But what if we wanted to return, let's say, a Boolean value to denote whether or not the message sent was successful? So what we can do is we can use the colon, and then after colon, we can specify the data type. So let's say Boolean. We want this function to return a Boolean value. Okay, so we have function output message, we have parentheses, and inside the parentheses we have the function parameters, and then outside we have the colon again, and then we have the data type. Okay, and then the curly braces over here. So right over here, this will annotate the return type of the function. All right, so hopefully that makes sense. Now I actually, let me see if I can. I know there should be an error, or not an error, but I think no implicit returns is what we want. So let me actually remove this, because this should give us an error somewhere. Well, maybe not an error, but it should at least. I want it to basically have a red line if the return type is not explicitly declared. So let me actually see if I can do that by changing this. Seems like it doesn't want to. Seems like it doesn't want to work. Though I might be using something different. I'm not sure. But what I'm going to do is I'm going to set the return type to a Boolean, and we're going to return true. Okay, and so yeah, this function will just always return true. It's pretty much not really a significant return type, but obviously if it was more complex, you would have a bunch of if statements, some conditionals, and then based off of some condition, you would return true or false. But now if I hover over here, you're going to see that it says in the IntelliSense, function output message, this is the signature. We have one parameter, and then it returns a Boolean. Okay, and we can obviously assign that return value into some variable. So const was sent is a Boolean, and we can do something like if was sent, console log, message was sent successfully. And this is just a simple if else statement. Else we'll just say console log, message failed to send. And now if I compile this down, and I'm going to go ahead and run the index.js file with the node interpreter, you're going to see a message was sent successfully. Okay, and that's pretty much the basics of function type annotation, or function return values, explicit return values for functions. And this could be anything. Like I said, this could be undefined. Okay, this could be a string. This could be a number. This could be an object. You can even create your own classes or interfaces, and you can actually annotate that. But we're going to talk about that later when we actually get into classes and interfaces and the custom types. Okay, but hopefully all of this stuff made sense. These are just the basics of type annotations. So in the next part of this video, we're actually going to get started. We're going to talk about classes and a little bit of OOP in TypeScript. All right, so in TypeScript, we actually also have a bunch of more OOP features. So let's actually start off with going over classes in TypeScript. So I'm going to create a file. I'll call this computer.ts, and we're going to create a computer class. And it'll have a couple fields such as RAM, CPU, and a bunch of other things that we need. So let's use the class keyword, the same thing that we would do in JavaScript. The syntax is pretty much the same, though, like I said, there are some many differences. So we can actually use access specifiers to define our fields. So for example, we have public, private, and protected when it comes to access specifiers. And if we have a public field for a class, that means any file can actually access those fields, right? Anywhere it can be accessed. If we have private fields or methods, only the class itself can actually access those fields or methods. And I'll show you guys how that works in just a second. Okay, and with protected, it's a little bit it's very similar to private, though there is like some slight differences. But we're only going to mainly talk about public and private. So I'm going to go ahead and first declare a field. Private, I'll call this CPU, and we'll just give this a string, and I'll just say Ryzen 3900X. Okay, and I'm going to go ahead and create a constructor, just a simple constructor. And now what I'm going to do is I'm going to create an instance of the computer, just like this. Now notice how if I do C dot, I actually cannot even reference this CPU field because it's private. But if I change it to public, I will be able to reference it like that. Okay, and like I said, there's also the protected field as well. And notice how the protected, it kind of works similar to private, but like I said, there are some differences. Okay. But yeah, we're gonna change it back to private. We're also gonna create a field called RAM, and we'll give this a number data type, and we'll just say 32.0. All right, so now, why do you want to set your fields to private? Well, you want to follow this practice in OOP where you want to have all of your fields declared as private, and you want to use what's called an accessor and mutator function to actually either update the value or retrieve the value. So this is a common practice that people use in OOP. So what we do is we typically create the field names, and then you want to create what's called a getter. And the getters and setters, okay, there's a getter and a setter. The getters are pretty much responsible for getting the value. So we usually do something like public get CPU, return this.cpu, and we can do public get RAM, return this.get RAM. And now since these are public, RAM. We can actually do c.get RAM. Wait, let me change that. Sorry about that. And now, instead of directly referencing the field, we are calling a method that's going to get us the field. Okay, so this is a common practice that is used, widely used in the industry as well, and just literally anywhere. So let's go ahead, use TS node. There we go, 32. Okay, we can do the same thing with get CPU. Now, JavaScript has its own getters and setters feature. So instead of actually having to, call this function, you can actually treat the fields as an actual property. And I'll explain what that means in just a sec. So usually what you can do is you can declare your fields with an underscore like this. And then what you can do is you can do something like get. That's the keyword get. You can give it the name, whatever you want. And then return this dot CPU like that. And what you can do now is now we can create the instance of the computer class. And now you can notice how I can reference this CPU. So this CPU is basically a function that's going to return the CPU's value, the underscore CPU's value. But we can actually reference this as if it was a field rather than actually if it was a function. So notice how before we had to do something like get CPU, and then we had to call it. Okay, even though CPU is a function, but with the get keyword, we can treat it as if it was an actual field. And we can do the same thing with CPU, with setting it. So set CPU, CPU string, this dot CPU equals CPU. So I can do something like CPU equals, I don't know, Ryzen 3950X or 3960X? I don't know what the other one is. We'll just do 3800X. We'll downgrade. And let me go ahead and console log it. So let's run it. And now you'll see that it says Ryzen 3900X. So we call the getter, and then we call the setter over here to assign it the new value. So yeah, if we were not to do it this way, if we weren't to use the get and set keyword, we would obviously have to create our own setter as well. So set CPU string, just like that. This not CPU equals CPU. And it would work the same way, but the only difference is that when we do set CPU, we'd actually need to pass in the value like that. So it's really up to you on what you prefer. But I just wanted to show you guys how you can do it with setters, with the getters and setter keyword, the get and set keyword. Okay, so that's pretty much something simple. That's pretty much a simple implementation of a class. Now we also can do something like this with the constructor. So let's say, for example, instead of declaring the fields up here like that, let's say we want to pass in some fields into the constructor. So what we can do is we can actually do something like private CPU string, private RAM number. And what we can do is we can create a new instance of the computer, but we need to pass in the values. So let's say Ryzen 3900X, 32.0 for RAM. Okay. And now I can simply create my getters and setters. So return this -CPU. So this is just pretty much a shorthand way we can do that. So if you wanted to do it the long way, what you would do is you would do something like private CPU string, private RAM number. Okay, you would define your fields first. Okay, and then what you do is you would say this underscore CPU equals CPU. Whoops. and then this underscore ram equals ram. Okay, you would do it like that. Well, actually, we have to get rid of privates. So you would do that, okay? If you want to actually define it first and then assign it. But if you actually just leave it as this with the private keyword, like that, it'll just be a shorthand of what I just showed you. Okay, and you can actually use the this keyword to reference the fields. So this dot underscore CPU. So let's go back and let's return this dot underscore CPU. Let's create the setters as well. So remember, the setter is pretty much the mutator, which allows you to mutate, update the value of the field. And the getter is just responsible for accessing. It's the accessor. It just accesses the value. It doesn't do anything else. Okay, so this dot ram equals ram. Okay, so now let's first console log c.get, not c.get, c.cpu, c.ram. Now let's then change the value. So CPU, let's change it to Ryzen 3800X. And then c.ram equals, let's change it to 16.0. Now let's console log c.cpu, c.ram. And let's see what happens. There we go. Okay, so we first get the values that we initially passed into the constructor, then we updated it, and then we get it again, and you can see that we have 3800X 16 right there, 16 gigs of RAM. Okay, so that's like I said, a short way of how you can pretty much pass in and assign the actual field itself. Okay, so that's pretty much it with classes. So now we're going to talk about interfaces, and we're going to talk about interfaces, what they are, and how we can use it with classes, and why we should use interfaces. Alright, so if you came from a programming language like Java or C#, interfaces are pretty much, you can think of an interface like a class where you can define methods, but those methods actually do not have an actual body. It doesn't have an implementation. They just pretty much are responsible for describing what the actual functionalities are responsible for. And then we allow classes to implement those interfaces and then actually implement the implementation of those methods. Now in TypeScript, there's actually a couple ways you can use interfaces. We're going to go through each one of them. But the first way I'm going to show you guys how to use interfaces in TypeScript is how we can use it to program to the interface rather than programming to the actual implementation. So what we'll do is we'll create an interface and then we're going to implement it. Okay, but first of all, what exactly are interfaces, right? Well, interfaces pretty much allow us to abstract our programs, and we can create a class-like structure, group together all the fields and methods where a class can later on implement. Okay, so one main thing with interfaces is that it defines the behavior of what an object will have. So we don't actually have to worry about the underlying implementation. Instead, we can just focus on the actual behavior of the actual class from a high-level overview, or not class but object. So let me try to walk you through a simple example. So let's just say you have an animal class, right? So let me create an animal class. And let's just say if you know the basics of inheritance in JavaScript, well, JavaScript has inheritance, and it's the same thing in TypeScript. So let's say we have an animal class, and we know that there are other animals out there like a dog as well as a cat. And an animal class might have all of the basic fields and methods that every other animal can share. So for example, animals can make a noise. So let's just first extend the animal class. Okay. And let's just say that we know every single animal can make noise, but here's the thing though, we don't know which animals make what types of noise, right? So for example, each animal will make its own unique noise. Dogs will bark, cats will meow, birds will chirp, and etc. We cannot assume that all of these animals make the same noise, but we can definitely assume that each one of them will make some kind of noise. So what exactly do we do in this situation? Well, what we can do is we can create a structure, an interface that defines the behavior of each one of these animal instances. It doesn't tell us what it is. We just define what the behavior is, right? It makes a noise. What is a noise? Well, we'll allow the class to take care of the implementation. Okay, so what I'm going to do is I'm going to go ahead and create an interface. And I'll do that. I'll actually get rid of these first, and I'll do that right over here. So interface, animal. I'll actually just call it iAnimal, not the greatest name. But let's create a method called make noise. And you'll notice how we have make noise. It does not take in any parameters, and the return type is void. Okay, we can actually leave the return type to whatever we want, but we'll leave it as void. Now, what I'm going to do is we're going to say, okay, what's next, right? What do we do next? Okay, well, we know class animal can implement this iAnimal interface, but the problem here is that this assumes that the animal class will need to also implement the make noise method. But remember what I said, dogs and cats make different noises, so we technically should not actually even be implementing the interface at the animal level, but we should be implementing it at the dog or cat level, like the subclass level. Okay, so let's create a class called dog extends animal, and the animal class will just take in a couple of fields. So private, let's do private name, string, private age, number. Just two simple fields. Okay, and we'll create the getters and setters. So get. Well, actually, I'll just do a getter for now. Okay, return the age of the animal. Whoops. All right, there we go. Okay, so, and now the dog, since the dog extends the animal class, remember this is inheritance, okay? Since the dog extends the animal class, it'll inherit all of the fields. So we don't actually need to pass in a name or age for the dog. So I can do something like, we don't actually have to create a constructor for this dog. He'll inherit those. So I can do something like const dog equals new dog. And I can pass in, let's call it Andy, and let's just say 2 years old. Okay, now since dog extends animal, we also need to make sure we call the superclasses constructor. So what I'm gonna do, or actually I don't think we need to do that in TypeScript. It's a little bit weird, but it should work just fine. I know TypeScript's features are a little bit strange, more stranger than other languages. So something that you'll have to get used to. Oh wait, TS node. Okay, there you go. To Andy, perfect. Okay, so let's go ahead and implement this iAnimal interface. So implements iAnimal, and now you're going to see that we have a red line, and you're going to see it says class dog incorrectly implements the interface iAnimal, and that's because we need to actually create a concrete implementation of this make noise function. Okay, so basically whenever you are using interfaces, what you're doing, or when you implement interfaces, what you're doing is you're creating a contract between the interface as well as the class that is implementing the interface. So all of the methods that are defined in the iAnimal interface needs to be explicitly implemented in the dog class. So how do we do that? Well, make noise, void, and now we just do whatever we want. So now we can actually work on the implementation. In the interface, we don't have the implementation, we have the definition. Dog goes bark. Okay, and if we want to be more explicit, we can do something like this dot name is barking. Okay, so now what I can do is I can do dog dot make noise, and I can go ahead and run this. Andy is barking. See how that works? And any other method that I want to define for the behavior of our dog, I can actually, or not dog per se, but the animal itself, I can actually define that inside here. Okay. Now there's actually a problem, because technically, if we were to actually make this as generic as possible, what we would probably want to do is we would probably want to actually make it so that all of these methods are for all animals. So for example, what do all animals share? They share For example, making noise. They can also eat, run, certain activities, do something, right? They share a lot of different, not different, but they share a lot of similar actions that they would do, but they do it differently. So for example, do something could be different between a dog, cat, rabbit, etc. Okay, and you can see we can create that method definition inside our interface, but now we need to implement it like that. Okay, so let's just do this.name is doing something. And there you go. So I can do dog do something. And let's run it. There you go. Okay, so let's create one more class. Let's create a cat class. Let's extend animal. Let's implement iAnimal. Okay, so now we need to implement those two methods from the iAnimal interface. Let's do that. And we'll just say is meowing. Okay, is scratching the door. Okay. So what we've done was we extended the animal class for our cat because a cat is an animal. So we're going to inherit all of the fields such as the name and the age. And we implemented the iAnimal interface, which has all of our, which defines the behavior of these animals. Okay. So let's go ahead and implement the constructor. Actually, like, so we don't need to. And what I'll do is I'll say const cat equals new cat. And let's call this John, and let's give the age of 3. So watch this. If I do cat.make noise and then cat.do something, watch what happens now. So Andy is barking, Andy is doing something, John is meowing, John is scratching the door. So you can see how that although we have the same method, those methods implementations are different. So this is a very, very powerful usage of interfaces. You can basically create the definition to describe the behavior of the object, but you can leave the implementation for the actual class itself. So we know that cats and dogs obviously do different things. They make different noises. Okay, they eat different foods. So what we can do is we can actually define the method, okay, in the interface, and then we can implement the interface and then actually implement the concrete implementation of the method itself. So hopefully this gives you a brief understanding of how we can use interfaces. Remember, like I said, it's a contract relationship between the class and the interface itself. So every single method inside the interface needs to be implemented. Okay, so hopefully all of this stuff makes sense. We're going to go ahead and look at the other use cases of interfaces, and then we're going to go ahead and talk about abstract classes. So we're going to try to kind of like tidy everything up, and we're going to use abstract class instead after. But let's go ahead and talk about another way we can use interfaces in TypeScript. All right, so now I'm going to show you guys how you can use interfaces in a different way. You can actually use them to type annotate your objects. So let's just say, for example, I'm going to go into my index.ts file, and what I'm going to do is I'm going to create a custom object. So let's just do const custom object, and we'll give it some fields. So name will be, let's do Anson, let's do age 23, is male true, hair color dark brown. So right now this data type for custom object is any. Okay, and you'll notice that if I were to do string, it's going to give us an error, right? Type whatever this is not assignable to type string. I actually shouldn't say any, but it does have this structure. Okay, but let's go ahead and actually create a strict type for this interface, because sometimes we might want to reuse like a certain data type over and over again. That way we can actually ensure that that object has all of the correct fields. So let's create an interface. So it's the same way that we did it in the previous section. And we're going to give it, let's call it a person type. Okay. And this interface, what we're going to do is we're going to go ahead and instead of defining methods, we're going to define fields. So name string, just like that. Now, you actually cannot assign, or you cannot actually initialize the variable with interfaces. Okay, because remember, like I said, the interface pretty much is a contract relationship between the interface and the class or object. So we need to make sure the object actually has that field initialized. So we're just going to take all of the fields that we see here, and we're going to annotate with the correct data type. So age is male boolean, hair color string. And now what I'm going to do is I'm going to go ahead and just get rid of all these for now, and watch what I'm going to do. I'm going to say custom object colon person type. And now you're going to see that it's going to say type is missing the following properties from type person type. Name, age is male, hair color. So notice how that it's giving us this red line. That's because we are missing all of these fields. So for example, if I just type N for name, you're going to see that it pops up in the IntelliSense. Okay, so I can just say whatever name I want. So I'll do Drew. Age, I will do 20. We'll do 22. Is male, true. Then hair color, we'll do brown. And there you go. Now, if I try to add any additional fields that is not explicitly, well, explicitly but not defined in the person type. So let's just say if I added favorite food, pizza, you're gonna see it gives us this red line. That's because favorite food is not defined in person type. So I can actually do that if I want to, just like that. And the error goes away. So pretty much this is a good way for us to create objects with type definitions. So if we wanted to pass this into a function, that function will take in this object as an argument, and then we are 100% sure that it has all of these fields. So it's more explicit, it's more robust. If you want a specific field to be optional, let's say our person type, well, let's say our object Drew, right, does not have a favorite food. So favorite food might be not present, right? So if I get rid of it right now, it's going to say, hey, look, you need to have favorite food. But if I use the question mark operator at the end of the variable name, that means that this is optional. In other words, it also implies that this data type can be either a string or undefined. So you can do string or undefined, right? But even if you do string or undefined, you actually still need to explicitly define that value. But if you just did favorite food question mark, all right, that will save you the time without needing to actually do favorite food undefined like that. So if it's present, then it'll be there. But if it's not, then that's also fine too. Okay, so this is very useful when you have a field that can either be defined or undefined. Okay, so hopefully that makes sense. So that's one way that we can actually use interfaces for our objects. Okay, now if we want to, we can also create a function. So let's just say say joke. This is a function. Let's do an arrow function. And then what we'll do, actually, you know what? We'll just say joke, and let's see what I want this to be. Okay, there we go. So say joke will be a function, and now it's going to give us an error. It's saying that it's missing the say joke. So we can create an actual concrete implementation. So I'll just say joke is an arrow function, console.log, and we'll just say hello world. Not really a funny joke, but if I do custom object, say joke, and let's run index.ts or ts node, it's going to go ahead and say hello world. Now let me go ahead and console log custom object. Whoops. There you go. So you can see we have the object being logged, and we also have the hello world over here. Okay, so that's pretty much another way that you can use an interface. You can use it to pretty much type annotate an object to make sure it has all of these specific fields and methods if there are any. Okay, but a lot of times you might just use it just to explicitly annotate an object that you know will always have certain fields. So let's say, for example, if you're using Express.js or some kind of backend API framework, the request object usually has non-deterministic data for the request body. But let's say, for example, if you know for a fact that the request body must always have these specific fields. You can create an interface for it, and you can type annotate the request body. Okay, and you can also, create a function. Let's just say function get person, and let's just say it always needs to return a person type. Okay, so remember, this is an explicit return type for the function. So now we can explicitly return a person with all of the fields, like a name. Let's just do Danny, age 22, is male true, hair color, let's do black. Okay, there we go. Return this whole thing, and then we can console log call get person. And then there we go. So it prints out the object itself. All right, and like I said, you can also even pass this into a function. So let's just say function, I don't know, update person, takes in a person, and it needs to be a type of person type. And let's just set the return type to void, and we'll just do updating person. And I can go ahead and I can do update person, and we'll just pass in custom object, just like that. So now you're going to see it says updating, and it just prints out our object. Okay, so it pretty much works the same way as the already existing data types in TypeScript, but you can actually create your own data types. I wouldn't say they're data types, I would say they're custom types that you can use them as types, surely. Okay, but yeah, hopefully this makes sense. So these are pretty much, this is another common way that you would use interfaces aside from the way that we did in the previous example. Okay, so I thought I'd just go over this. So hopefully it all makes sense. So what we're going to do in the next video, or not video, but in the next section, we're going to go ahead and talk about abstract classes. And we're going to kind of like, compare abstract classes to interfaces a little bit. And then we'll talk a little bit more about the other functionalities of TypeScript. Trust me, there's a lot of stuff in TypeScript, so you definitely want to miss it out. All right, so in this section, we're going to talk about abstract classes and abstract methods in TypeScript. So what I'm going to do is I'm going to get rid of this whole implementation, or all the code inside animal.ts, and we're going to actually create an abstract class for our animal. Because remember how I mentioned that animals can have an abstract method such as make noise, because that make noise method the implementation can differ depending on what the animal is. So the cat, dog will make different noises. So we want to make sure that those specific methods can actually be abstract, and we allow the actual class itself, let's say the dog class, to implement those abstract methods. So in our previous example, we had an interface do this, but we can actually make this a lot more, we can actually improve this by using an abstract class. Because I didn't really quite like how we had to extend the animal, and for every single animal we needed to implement the animal interface. I didn't really quite like that. What I would prefer to do is we just have one class itself that implements an interface, or at least has some abstract methods that other implementations can implement. But let's not worry so much about that. Let's actually go straight into abstract classes. So what we can do is we can use the abstract keyword, or let's see, abstract class animal. Okay, so you can see we have abstract class animal. And a couple of things that I should mention with an abstract class is you cannot instantiate an abstract class. Okay, so let's say, for example, if I try to do const animal equals new animal, it's actually going to throw an error. It says cannot create an instance of an abstract class. However, we can actually create an instance of a class that extends an animal. In other words, we can also extend the animal class. Okay, so let's just say, for example, our animal, let's see, has a couple fields. Let's say private name, string, private age, number. Okay, and let's just also say we have a couple of methods that exist on this abstract class. So abstract make noise, void, abstract do something, void, abstract eat void. Okay, now let's go ahead and create a concrete implementation of our animal class. So we have all of our fields, and now we have all the methods. So class dog extends animal. And now we need to make sure that we are implementing all of the abstract methods. Okay, so when you implement an abstract method, you're basically creating a concrete version of it. So I'm just gonna go ahead and do inherit or implement all. Let's do that. Okay, and now watch this. So I'm gonna create an instance of the dog class. I'm gonna give it a name, so let's just call it Jack. Let's give the age of 3, and let's just change up these implementations. So for make noise, we're gonna go ahead and say console.log this dot. Let's see. I don't have a getter or setter, so let me just create that real quick. Okay, there we go. So this dot name is barking. So this is the concrete implementation. Now let me go ahead and do the same thing for do something, and eat is running laps, and eating is eating their favorite food. So now I can go ahead and do dog.makeNoise, dog.do something, and then dog.eat. Whoops. And now let's go ahead and run this. And you're gonna see, oh, we're running the wrong one. Sorry about that. Let's do animal. Jack is barking, Jack is running laps, and Jack is eating their favorite food. Okay, there we go. So we have our abstract class, and we have all of our abstract methods. So abstract methods, you can think of them very similar to how we had the interface with the method definition, but no actual method body. Okay, and the whole point of all of this is to practice data abstraction, where we can hide certain details and only showing certain essential information rather than actually having them worry about the implementation. The implementation, we can allow the concrete implementation, like the dog class, to implement it for us. Okay, so a couple things, like I said, just remember that abstract classes cannot be instantiated, so I cannot do const dog goes new animal. I can't do that. Okay, can't do that. And you can also actually create non-abstract methods. So let's just say, I don't know, some method, bad name, but, and this would basically be a concrete method rather than an abstract method. So if I do dog.do something, not do something, some method, that this will also work. Okay, but if you actually don't implement it inside the dog class, that'll also be fine as well. Well, actually, you could override it, actually. So let me show you an example. Let's just say console log animal is doing something. So let me get rid of this sum method, and let's call it. It's going to say animal is doing something, but you can actually override this method in the dog class. Let's do this dot name is watching TV. So you'll notice now it's going to go ahead and say Jack is watching TV. So you can actually create a concrete method in the abstract class, but you can also override the implementation if you really want to. Okay, but let's say this is some method that every single animal is going to share. If you don't want to override it, you don't need to, but it's there. Okay, so that's also something nice to know. All right, so that's pretty much it when it comes to abstract classes. So personally, I would prefer using an abstract class for this specific scenario compared to the way that we did it before, because the way that we did it before, we needed to have every single animal implement the iAnimal interface. But over here, we can actually just create an animal abstract class, and we can have every single animal extend that animal class and implement all of the required abstract methods. Okay, so that's pretty much really all there is for abstract classes and abstract methods. And like I said, by using this concept, you're practicing data abstraction and you're hiding important details away from the user. Okay, and you're only showing specific details rather than things that they don't need to worry about. So anyways, so hopefully all of this stuff makes sense. Hopefully you have a better understanding between abstract classes and interfaces. They're very similar in some ways, right? That the abstract class as well as the interface both have abstract methods that need to be implemented. Okay, but I guess it depends on the use case, on whether or not you want to use an interface or an abstract class. So anyways, in the next section of this video, what we're going to do is we're going to talk about enums, and then we're going to go into other things such as custom types, and then we're going to talk about generics. And then if that's all there is to it, we'll probably go over some other like actual scenarios of how we can use TypeScript with existing APIs and modules. Alright, so in TypeScript, we also have something called enums, which is short for enumerated types. So enums are very great for things that can be represented as constant values. So usually these are just like a set of named values, and you can reuse them over and over again to represent some kind of constant value. So let's just say, for example, you're writing some kind of program, and that program might have a set of error messages. Okay, so instead of having to hard code the error messages, because you might need to reuse it over and over again, and if you were to change it in one place, you would have to change it everywhere. Instead, if you place it in an enum, you can just change the value. You can just change the message where you create the enum, and then it will just update everywhere. So to create an enum, it's actually fairly simple. We use the enum keyword, and then we can just call this error underscore messages, just like that, or no equal sign, sorry. And then now what we can do is we can create the actual enum, the actual field, I guess you can call it. But typically I like to name the fields with all capitalized letters, because we're representing constants. So we'll just say something like, let's say unauthorized, and we'll just say you are not authorized. Okay, so now let's create another constant. So let's do forbidden resource, bad request, and etc. So now what I can do is I can actually just simply reference this enum, and you can see I can reference any one of these constants. So I can reference unauthorized, I can reference forbidden, I can reference bad request, and again, like I said, we can create a bunch, and these can be any value, like the data, they can be any data type. So you can also have numbers as well. So let's say enum status codes. I keep forgetting there's no equal sign. Let's just say success will be 200, bad request will be 400, server error equals 500, and we need colons, or not colons, commas. Forbidden is a 403. These are actually HTTP status codes, in case you guys didn't know. Unauthorized is 401. Let me actually move this here. Let me just put them in order. Created is 201. There we go. So now I can, like I said, I can also reference these as well. So status codes, success. And let's go ahead and run these now. There we go. See how that works? So like I said, this is pretty much all it is for enums. They're very, very simple concept to grasp. Like I said, they're just a set of constant values. Okay. There's really not much there is to it, if I'm being honest with you. Okay, so hopefully all of this makes sense. You can also use enums as a data type if you want. So let's say, for example, const error message needs to be an error message. It needs to be one of these error messages. Okay, so for example, if I try to do something like this, it's going to give us an error. Type whatever this is not assignable to type error messages, but it has to be one of those. So for example, unauthorized request. Okay, so yeah, you can pretty much use this as custom type if you want, and I'll let you guys play around with that. You can pass into functions, you can have the function, you can explicitly declare the function returns an enum of an error message, and a bunch of other things. So hopefully all of this stuff makes sense. So in the next video, I'm going to talk about custom types. Okay, so I'll see you guys in that video. I'll see you guys in that section. Alright, so in this section we're going to talk about literal types. So pretty much in TypeScript we can create our own custom types. We'll start off by talking about literal types. So right now we know, let's say for example, if I declare a variable called message, we know that this data type, the data type of message, is going to be a string. Okay, but let's just say if we wanted to have a more explicit type, right? Because technically we know that this is a message, but what if it's more than just a message, right? So what we can do is we can use the type keyword, and we can basically create our own custom type, and this is called a literal type. So for example, the message can either be, hello. Okay, so let's go with this for now. And what we'll do is say const message equals, or not equals, we'll type annotate to message, and you can see how it pops up in the IntelliSense. Now obviously we probably don't want just one message, we may want multiple. So we can use this slash, and we can join it with other literal types as well. So let's say hello, goodbye, good morning. And now if I try to assign any literal value, you can see that in IntelliSense it pops up good morning, goodbye, hello. So this is a good way to create your own custom types that are explicitly defined, like the actual literals are explicitly defined. So it's kind of very similar to how you can use enums in a way, I guess. The only difference is that you define these types with literal values. Okay, so the type message can either be hello or goodbye or good morning. Okay, it cannot be anything that is not one of these three. So let's just do goodbye. Okay, so that's pretty much it with literal types. We can also do this with numbers. So let's just say type, I don't know, status code, and we'll do 200 or 201, or let's do 400 or 401, 403, 404, or 500. So the most common ones. So now we can go ahead and say const status, which is going to be status code, and it can be either one of these 7 numbers. So 400 would be fine. Let's see what's going on over here. I think status might actually be already used somewhere. There we go. Alright, so yeah, there we go. So we can do 400. If I try to do 405, it's going to have this red line. So pretty much any one of these codes would be valid to be assigned to this variable. 201 would be fine, 200, 203 won't work. Okay, so pretty much that is simply it for the actual numeric literal type. And we can also do the same thing with booleans if we want to. So type is male, and this can be either true or false. Const is male, though this wouldn't really quite matter too much, but if we try to do a string, you're gonna see it doesn't work. Okay, so that's pretty much it with when it comes to types, literal types. Okay, now another thing that you can also do is you can actually have union and intersection types as well. And notice how we can actually join other types. So for example, let me do one more thing. Let's do this. Let's do type success codes, and let's just do 200 and 201. We'll do type error codes, will be 400, 41, 403, 44. We'll do type server error codes 500. And what I can actually do is I can actually join all of these together. So it can be like status codes will be success codes or error codes or server error codes. Const status code. If I try to do 501, wait, whoops. If I try to do 501, it's not going to work. If I do 500 or 400 or any one of these, it'll work just fine. And basically over here, we're joining together. You can kind of think of it like combining all multiple types to create one, universal type, if that makes sense. Okay, so hopefully that makes sense. So to summarize, basically what we just did was we created a union type because you can have either one of these three types. Okay, so it can either be 200, and we basically join everything all together into creating one type. Okay, so hopefully that makes sense. We can also do something like this where some type can either be a string or a number. So const value some type can either be a string or it could be a number, just like that. Okay, so this is called a union type. Okay, now when it comes to intersection types, basically with intersection types, it literally means that the type itself will have all of such properties from both types, right? That's basically what it means by intersection. It's going to have all of those properties together. Union will group together everything. Intersection will pretty much have all properties from two intersected types. So hopefully that makes sense. So before I move on to generics, I want to talk a little bit about arrays in TypeScript real quick. So what I'll do first is let me create a person type. We'll just give it some basic fields. So let's do Boolean, and then favorite food. We'll have this as a union. Or let me actually create another type real quick. So type food, pizza, sushi, tacos. This will be a food type. I'm going to create an array, and I'll call this people. And in TypeScript, there's actually a couple ways, well, actually two basic ways that you can create or declare an array. Okay, well, first of all, in JavaScript, we just do this. But like I said, you want to do it the TypeScript way. So what I would do, and what I would suggest you guys do, is you type annotate this to be an array of person, or yeah, an array of the person type. Okay, so now if you were to create an object, it will ask you to provide all of the fields. So let's just do Andy, and then is name true. Okay, and then we will just copy and paste this. Let's do Emily false. Okay, now another way that you can actually annotate this array is you can actually use the array type, and you'll notice how over here, you'll notice how it actually shows a T. We're going to talk a little bit more about that when it comes to generics, but basically the reason why I want to talk about arrays first is because arrays are a generic data type, and what that means is that with that T variable, we can actually substitute it to be any data type we want, because technically in our array, we can have an array of any type. Okay, so right now, if I leave it like this, what I'm saying here is that this people variable, the data type is an array of person types. Okay, so that's pretty much a generic. I can also do it this way too, if I wanted to. Array, angle brackets, person. Okay, so this is a generic. So if you've used a language like Java before, you've definitely used something like, you've probably used array lists, for example, and array lists are generic. So let's say, for example, let me create another type. Okay. What's going on over here? Oh, it's probably because I have animal over here. That's why they're like in the same namespace. But let me change it to animal type now, and you'll notice how it's giving me this red line error. Okay, so right now basically I can have an array of animals, and I can say array animal type, and then I can say name Oscar, color, let's do blue. Okay, and like I said, you can also do it this way as well if you want to. The preferred way is to do it this way, but the reason why I want to show you guys this way is because this is the notation. So if you were to actually create your own generic classes or generic functions, you would need to use this notation to annotate the class or the function signature. Okay, so that's pretty much how you can deal with arrays and or in TypeScript, right? And this is basically saying, okay, we have an array of objects, and all those objects must follow the type of animal type. Same thing for the person array. We have to have every single object following the person type. So that means we can't actually just throw in random data like this, like that, like you would be able to do in JavaScript. So for example, in JavaScript, you could do something like this, something like that. In TypeScript, if you type annotate your array, then you are going to explicitly have the same instances in every single element. Okay, so hopefully that makes sense. All right, so now I want to talk about generics now. So what exactly are generics? Well, generics allows us to actually create classes and functions that can be reusable, and it basically allows us to have any type of data that we want. So instead of having our class boil down to just one specific data type that's being used, right? We can actually have it to be using whatever data type it is that we pass in. Okay, so let me go ahead and show you guys an example. And this is, if you want to look more into generics, I would suggest you look into generic programming. Okay, so let's just do this for example. Let's just say we wanted to create some class, and I'll call this random class. Okay, and what I can do is I can explicitly set the custom data type to be whatever I want by using the T annotation. Okay, so if you looked at the arrays example earlier, you would have noticed that array takes in this T variable. Well, it's not really a variable, but it's just to denote that it can take in any type we want. Okay, so this type can literally be anything. It could be a string, it could be a number, whatever it is that we want. So now let's go ahead and declare some fields now. So we'll go ahead and say public, let's say field A, and we'll set the data type to be T. Okay, now the problem here is that it doesn't have an initializer, so instead what we're going to do is we're going to set this to be a private field A T, just like that. Okay, so this can be literally any data type that we pass in for this parameter. All right, so now let's go ahead and create an instance. And what we want to do now is we want to pass in, we want to explicitly state the data type that we want. And we can do that by using the angle brackets right before the parentheses. So I'll just do string. And now pay very close attention over here. Right now, if you look over here, the data type is unknown. Okay, that's because we don't know what the data type is. So I can literally pass in the string and it'll work just fine, right? But let me actually do this. Let me pass in a number. Now let me go ahead and explicitly state that for the type T, we want it to be a string. And now it's going to say argument of type number is not assignable to parameter of type string. That's because we have said, hey, look, T, the data type, is supposed to be a string. So now you have to pass in 22. So if I were to go ahead and create a getter for field A, well, first of all, let me put an underscore before there. And what would be the return type? Well, it would be T. Return this dot field A. We don't want to explicitly state what it is because we don't know what the return type is, right? You're going to get type T is not assignable to type number. You want it to be T because T is whatever we explicitly state. So, for example, we say, okay, T is supposed to be a string. So that means field A is going to be a string, and that means the return type of this field A getter is going to be a string as well. If it was a number, you can replace all the t's with the number data type. This is a process called erasure. Okay, so I would highly suggest you guys look that up, erasure. All right, so now let's go ahead and do console log random class field A, and you can even see IntelliSense knows that it's a string because that's what we pass it in as. So if I were to run tsnode index.ts, it would give us back 22. Okay, so hopefully this gives you a brief understanding of generics. Okay, so pretty much, like I said, it allows us to create our own custom classes with pretty much any data type that we want, right? So we don't need to restrict it down to just, you know, a string or a number. We can pass in whatever we want, and then we can reuse it over and over and over again. Now we can also have function types or method types with generics as well. So let's just say, for example, let's call do something, and let's just say it's gonna take in whatever type t is. So let's just say args t. Let's just console log args. Okay, so if args is a string, then it'll be a string. If args is a number, it'll be a number. We can actually also even explicitly, you know, annotate it like this too. We don't need to have everything declared as t, or, you know, have it typed as t. So random class do something. Okay, now we have to pass in a string because the data type is a string. If I change this to number, then we have to pass a number for everything. Okay, so hopefully that makes sense. There you go, perfect. Okay. Okay, hopefully that makes sense. Now, if we wanted to just do it with functions, we can just simply do something like function do something. Okay, and we can say t, and then args will be type t. All right, so now this function is now generic, and we don't necessarily know what t could possibly be. It could be a number, it could be a string. So now if I wanted to, I can console log args. Now I don't know what the data type is. Okay, but we can also just infer it easily like that. But if I want to, I can say, hey, look, do something. Let's say this is supposed to be a number. But if I try to pass in a string now, it's going to throw that error because it expects a number. If I pass in a number, it'll work just fine. So if I were to run this, it would call do something, and t is now a number. Okay? Now it doesn't know it inside the function because it's generic. But hopefully this gives you guys a better understanding. Okay, we can also explicitly set the return type to like this though. You have to actually return whatever args is now. Okay, so hopefully this gives you guys a brief understanding of how generics work. If you guys want more examples, I would highly recommend you go over to the TypeScript documentation. They have a bunch of examples that you can go through. I just want to give you guys a brief understanding to it. Okay, so hopefully all of this makes sense. All right, so that's going to pretty much conclude this whole TypeScript tutorial series. I really hope you guys learned a lot. We did go over a lot of different things, and pretty much all I did was I just went over to the TypeScript documentation and I looked at all of the stuff on the sidebar, and I just covered everything to the best of my ability. Like I said, if you guys want to learn more about TypeScript, I would highly encourage you guys to go over to the documentation and read up a little bit of things, and also try to practice on your own by slowly creating a new project with TypeScript instead of using JavaScript. And that's going to be pretty much it. So hopefully you guys liked this video. If you guys did, please definitely leave a like down below, leave a comment, and I will see you guys in my next tutorial. Peace out.